Hey everyone, welcome back. This is lesson 10.7, solving nonlinear systems. The objective for today, you'll be able to solve systems of equations in two variables that contain at least one second-degree equation. Your vocabulary for today is nonlinear system of equations. A nonlinear system of equations is a system in which at least one of the equations is nonlinear. And you've been studying one of the classes of nonlinear equations, the conic sections. So let's just remember what a linear system is. A linear system is going to have an equation where, like mx plus b, where your x, the highest exponent on our variable, is 1. But with a nonlinear equation, that means our exponent is going to be greater than 1. All right, so now we're going to start doing the same thing with conic sections. The solution set of a system of equations is the set of points that make all of the equations in the system true, or where the graph intersects. For systems of nonlinear equations, you must be aware of the number of possible solutions. So let's take a look at those. You can use your graphing calculator to find solutions to systems of nonlinear equations and to check algebraic solutions. If you have no solutions, notice that the two, like in this first one, these two never intersect with each other, so there's no solution, there's no common point. Here, where the two graphs intersect each other, at one point we have one solution. Here, obviously, they intersect at 2 points, so two solutions, 3 and 4, and so on. Let's try an example. It says solve by graphing. So this is pretty simple. The graph of the first equation is a circle, and the graph of the second equation is an ellipse. So there may be as many as 4 points of intersection. Let's talk about what that would look like. So if our first example is a circle and our second example is an ellipse, the most that we could probably have is 4 points of intersection. So let's take a look at this example and try it. So we're going to solve each equation for y, keeping in mind that we could have as many as 4. So let's solve each equation for y. So we're going to take y equals plus or minus 25 minus x squared. So that was this first equation. I just subtracted x squared from both sides and then took the square root of it. All right, our second equation, solving for y again, you come up with this equation. And now we can easily put it into our calculator. And when we do that and graph it on our calculator, you can see that there are indeed 4 points of intersection. All right, so we have a point here, 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 and here. Hope you can see those big enough. So those are our points of intersection, and you can find them on your calculator by looking at the table on your calculator, or you can just do a trace and find all those points. All right, try this one on your own. Turn your video off and try solving it. Okay, so hopefully you were able to solve that just fine. Let's just go through it real fast. The first thing we wanted to make note of is that when you graph the first equation, you're going to get a line. And when you graph the second equation, it's going to be a parabola. So if you think about that for just a second, if I have a line and a parabola, the most points of intersection I can get is going to be 2. So I'm going to be looking to see if I have at least 2 or only 2 points of intersection. So when we solve each equation for y, you should have gotten these 2 equations, and then all you have to do is put it into your calculator, and you can see that actually there is only 1 point of intersection, and that's at 0, 4.5. The substitution method for solving linear systems can also be used to solve nonlinear systems algebraically. All right, let's do example number 2, solving a nonlinear system by substitution. So the first thing that you should recognize as you look at these 2 equations is that the graph of the first equation is a circle, and the graph of the second equation is a parabola. So at the most, there could be as many as 4 different points of intersection. All right, so once we keep that in mind, let's go ahead and solve. Since we're using substitution, I can solve for x squared and x squared because there's an x squared in both equations. So let's take a look at our first equation, and we're going to solve for x squared. So let's just add 26 to both sides, plus 26, and then multiply everything by 2. That gets rid of this. So that leaves me with 52. So when we do, we get x squared equals 2y plus 52. All right, so now that I've solved for x squared in the second equation, I can use substitution. So what I'm going to do is go ahead and substitute this value, x squared equals 2y plus 52, into the first equation. So in place of x squared up here, I'm going to put this piece of my equation. So I'm just substituting. So once I've done that, I can set that equal to 0. And now I can simplify and set it equal to 0. And I end up with y squared plus 2y minus 48 equals 0. And then I can factor that out, two numbers that multiply together to get negative 48, add together to get positive 2. I know that's 8 times negative 6. All right, so when I factor it out, I end up with y plus 8, y minus 6. All right, so let's keep that in mind. We see that y is either going to equal negative 8 or y is going to equal 6. So we've got our y's, so now we're going to have to substitute those back in to solve for our x. So we have y equals negative 8 or y equals 6. All right, so here they are. We're going to substitute our negative 8 and 6 back into one of our equations, our easy equation here, to find the value of x. So when I substitute in, I get x equals plus or minus 6. So I see that there are two solutions, 6, negative 8, and negative 6, negative 8. Okay, so that's when I substitute my 8 in, my negative 8 in. Now I have to, step 4, I'm going to have to substitute my 6 in. Okay, so there I substitute my 6 in, and here I get 2 more points. So now that I actually have 4 points, and that's all I need. So the solution set is this whole set right here. And again, you can use your graphing calculator, and the graph supports that there are 4 points of intersection. 1, 2, 3, and 4. All right, now you get to try one on your own. So turn your video off and try it. All right, so you're going to solve this system of equation by using the substitution method. So looking at what you have, what your first thing that you see is the graph of the first equation is a line because our highest exponent is just 1. And the graph of the second equation is a circle. So there could be as many as 2 points of intersection. All right, so we could have as many as 2 points or 2 solutions. So let's go ahead, and first thing we should do is solve for x. And so in the first equation, that's really easy. Just subtract y from both sides. And we have x equals negative y minus 1. So now that I've done that, I can just use my substitution and substitute that into my second equation. I'm going to substitute it in here and square it. And so now that I've done that, I'm going to just simplify and set it equal to 0. And I'm just going fast on this. You'll have to take the time and actually do it. So once we do that, we can see that 2y squared plus 2y minus 24 equals 0. So I can factor that. And when I do, I end up with 2. I factored a 2 out. And now I can factor again two numbers that multiply together to get negative 12, add together to get 1. So I know that's 4 and negative 3. So my final answer is 2 times y plus 4, y minus 3. Now that I've done that, I'm going to actually have some y's. So I know my y is either going to equal negative 4 or it could also equal 3. All right, so now I have my y's, so now I have to figure out what my x's are that match up with it. So I'm going to take my negative 4 and my positive 3 and substitute it back into our original equation because that's a nice simple one. So substituting, I see that 3, negative 4 is a solution. All right, and next I'm going to substitute my 3 back into the first equation, and when I do that, I see that -4, 3 is a solution. All right, so the solution set to this system is actually 3, -4, and -4, 3. Again, we can use your graphing calculator, and it supports your answer that we have a point here and a point of intersection here. So those are the 2 points where they have numbers in common. All right, here's another one for you to try on your own. Turn your video off and give it a try. Okay, so once again, we're going to solve using the substitution method. The first thing I want you to take note of is what your equations are. The graph of the first equation is a circle, and the graph of the second equation, notice it's got an x squared, but the y is not, so that's a parabola. So there could be as many as 4 points of intersection, okay? 1, 2, 3, 4. All right, so now that we know we could have as many as 4 points of intersection, we need to go ahead and start our substitution, and it's simplest to solve for x squared because both equations have x squared terms. So let's solve for x squared in the second equation because that's the most simple. So we can see that x squared equals -y plus 5. Now I can just substitute this x squared for this x squared, fill it in, not too difficult, and I end up with this equation. Now I'm going to substitute. I'm going to actually simplify, and I have y squared minus y minus 20. I can factor that. 2 numbers that multiply together to get -20, add together to get -1. That's going to be 5 and -5 and +4. All right, so now I factor that out, and I can see that y is going to either equal -4 or y will equal 5. Now that I have that, I'm going to have to go back and substitute again. So let's do that. All right, so I'm going to substitute my -4 and my 5 into my original equation to find values of x. All right, so when I substitute -4 in, I find that x equals ±3. So 3, -4 is 1, and -3, -4. That's going to be a solution. But remember, I just substituted the -4 in. Now I have to substitute the 5 in also. So when I substitute my 5 in, I find out that x equals 0. So I only have one more solution here. Now we said there could be a total of 4, but we see that there's actually only 3. So here's our solution set to that system. And now you can also graph it in your graphing calculator. And when you do that, we can see that there are actually just 3 points of intersection. 1, 2, 3. All right, so we can also use elimination method to solve systems of nonlinear equations. And remember, in example 3, you can check your work by using a graphing calculator. So just a little handy thing to remember. Okay, so this time we're going to use elimination. So let's take a look at our 2 equations. We're going to solve by using the elimination method. I hope you remember what that was. So when we look at this, the first thing I want to notice is what kind of graphs I have. The graph of the first equation is actually an ellipse, and the graph of the second equation is also an ellipse. I'm just going to draw another one like that. So there may be as many as 4 points of intersection. 1, 2, 3, 4, and there sure are. All right. So now for solving this, let's just eliminate y squared because notice I have a 25y on both sides, so that's going to be pretty easy to eliminate. So the first thing I want to do is just go ahead and subtract the first equation from the second equation. All right, so when I do that, I'm just subtracting, so I'm going to say -36 and a -25. So 4 minus 36 is going to be, here we go, 32x squared equals 128. Now that's not too hard, so the next thing I just need to do is solve for x. So I'm going to divide both sides by 32. I end up with x squared equals 4, so x equals plus or minus 2. So that's really helpful for us. So now we have some x's. So next, knowing that x equals plus or minus 2, we're going to find the values for y. And all we have to do is just substitute 4 for x squared because x squared is 2 squared is 4. All right, and so plugging that in, and then we just have to simplify. We got 16 plus 25y squared equals 41, and now just simplifying some more, we end up with y equals plus or minus 1. So I had a 2 and a minus 2. All right, and I also have a plus or minus 1. So here are all my answers: -2, -1, -2, +1, +2, -1, and +2, 1. Okay, try this one on your own. Turn your video off and see if you can do it on your own. All right, again, we're solving by the elimination method, and I can see easily that the graph of the first equation is an ellipse, and the graph of the second equation is a hyperbola, because notice it's minus, all right? So that's going to be something potentially like that. And so we could have as many as 4 points of intersection. There we go. All right, so to eliminate, we're going to subtract the first equation from the second equation because they were both had 25s there, so that was really easy. And we end up with -25y equals 175. So next we're just going to solve for y, and notice I end up with y when I divide by -25 on both sides. I end up with y equals -7. Now remember, y squared equals -7, so in order to solve for that, we would have square root of -7, and that's actually an imaginary number because remember, no two numbers can multiply together to get, no two the same number can multiply together to get -7. So this is imaginary, so there is no real solution to this system. All right, so let's put all this information into a real-life problem-solving application. Suppose that the paths of two boats are modeled by the two equations. How many possible collision points are there? So the first thing we want to do is understand this problem. And what it's saying is that there is a potential danger of a collision if the two paths cross. The paths will cross if the graphs of the equations intersect. All right, so let's understand what our problem is. We're going to list the important information. So we have two equations. The first one represents the path of the first boat, and the second one will represent the path of the second boat. So next we want to make a plan. So to see if the graphs intersect, we need to solve the system of equations, which is what we've been doing in this lesson. All right, so our third step is to solve. And so let's just first of all take a look at our equations. We notice that the first graph of the first equation is an ellipse, all right? And the graph of the second equation is a parabola. There we go. So we know that if we have an ellipse and a parabola, we have as many as 4 points of intersection, so 4 opportunities for the boats to collide. So let's go ahead and solve. And so let's take a look at the second equation and solve for x squared. So when we do that, we see that x squared is actually equal to 4y plus 24. All right, so now that we've done that, we can substitute this value into the first equation. So there it is. And then we're going to simplify it and then set the equation equal to 0. And now, oh, look at that ugly thing. Okay, it doesn't look like there's really anything I can factor out of all of this. And it looks like it would be really hard to factor. I'm not even sure that it can factor easily. So let's remember our quadratic equation. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And remember, our coefficients are a, b, and c. So we're going to have to use that quadratic formula, substitute everything in. I'm making it nice and easy for us right now. I've already done it all. So when we do that, we solve and we end up with y is going to actually equal 0.24 or y equals -6 and y equals -6. So we have two y's there, which kind of makes sense to us. So now let's keep moving. So now we're going to substitute that y equals 0.24 and y equals -6 into one of our original equations, and this one seems the simplest to me. So let's go ahead, and when we simplify it in, we end up with x equals approximately, not exactly, but approximately plus or minus 5. So when we substitute our -6 in, we end up with x equals 0. So there are actually 3 real solutions to this system. All right, so there are 3 possible collision points. So let's just think about it for a minute and look back. The graph supports that there are 3 points of intersection. So if you put it in your calculator, you're going to solve and see this. There are 3, because the paths intersect, the boats are in danger of colliding if they arrive at one of the 3 points of intersection at the same time. So time and their position have to all collide in order for the boats to collide. All right, you get to try one on your own now, so turn your video off and see if you can do it. And the question says, what if? Suppose the paths of the boat can be modeled by this new system. Is there any danger of collision? Turn your video off and give it a try. All right, so here's our 2 equations. Let's see what we should do first. The first part is to understand our problem. So there is a potential danger of collision if the 2 paths cross. The paths will cross if the graphs of the equations intersect. So let's list our important information. The first equation represents our first boat. The second equation will represent our second boat. So we're going to make a plan. We want to see if the graphs intersect, so let's solve the system. So the first thing we want to do to solve is think about what we have. The graph of the first equation is an ellipse. All right, we have plus there. And the graph of the second equation is a parabola because I have y only has an exponent of 1, but my x has an exponent of 2. So I have an ellipse and a parabola, so I have a potential of 4 different collision points. So let's see if that actually exists in what we have. So what we want to do is solve the second equation for x squared. That's pretty easy because I have an x squared in both of these. If I solve one for x squared, then I can substitute. So that's an easy solving. X squared equals -10y minus 20. So now I'm going to just substitute that into the first equation. And so there I have substituted it right here. And next I'm going to go ahead and set it equal to 0 and solve. Once again, this is a really nasty, ugly problem. So I'm going to use my quadratic equation using my coefficients here. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we're going to use that quadratic equation. And there I've done it all for us so that we don't have to do that nasty work. But sorry, you'll have to on some of your problems. All right, so when we do that, we end up with y equals 18 or y equals -3.6. So now we have to go back and substitute again so that we can find out what our x's are. All right, so now that we have our y equals 18 or y equals -3.6, let's substitute it into this simplified part of our equation, which was this piece right here. And when we substitute 18 in, we get x squared equals -200. Uh-oh, we've got a negative number there. So when I square both sides, I can see that there is no real value because that would be imaginary. So now let's substitute in our y equals -3.6. And when we solve for that, we see x equals plus or minus 4. So that tells me that my 18 is out. I'm not going to have any points of intersection with 18, but I am at -3.6. I'm going to have a -4, and at -3.6, I'm also going to have a +4. So here we have it. There are 2 possible collision points. So, and you could also put it into your calculator. And when we do, the graph supports that there are just 2 points of intersection here. Because the paths intersect, the boats are in danger of colliding if they arrive at the same intersection at the same time. Okay, next. Here's just some sample solving by graphing, solving by substitution, and solving by elimination. Turn your video off and give these a try, and then I'm going to give you the answers, and then we'll be done. Okay, so I'm not going to work them out for you, but if you did it, your possible solution could be plus or minus 6, plus or minus 2. All right, our next solution is going to be plus or minus 5 and plus or minus 2. And our last one is going to be plus or minus 3, plus or minus 2. So I hope you were able to get those right. And if not, we'll work on them some more in class. All right, you guys have a great day, and I'll see you in class. Bye.